Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps at some of the world's best companies as quickly as possible. I've spent quite a bit of time in the past few lessons talking about classes because they're so integral to .NET. In fact, just about everything you do in .NET somehow involves a class. And we talked about the .NET Framework class library, which is just a collection of classes that contains functionality that you can use, but you don't have to worry about writing yourself. You didn't have to create any of that. Microsoft already spent tens of thousands of man hours writing code, and you can just borrow it. And that was really the purpose of learning more about inheritance in the previous lesson. We said that Microsoft has created the classes in such a way that there's this rich inheritance hierarchy. It's a means of specializing and extending base classes. In some cases, it's beneficial to Microsoft because this allows for code reuse and ease of maintenance. In other cases, it's more beneficial to the end users, you and I, because we can leverage knowledge about, for example, how streams work to all types of specialized stream-based classes for working with file data, network data, database data, and so on. So the .NET Framework class library is composed of a rich set of inheritance between the classes. But because I really want you to understand how the .NET Framework class library was put together and how it works, and most of all, how you can get the most out of it, I want to talk about one final topic related to all this, and that has to do with understanding how code is organized and how to access some code that isn't just added to your project by default. So we're going to talk about namespaces, and we're going to talk about assemblies, and we're going to talk about adding references to external assemblies using the Visual Studio IDE. So what we want to do is create a new project, and it's going to be called Namespaces and Referencing Assemblies. It's kind of a long one. All right. So first of all, within the .NET Framework Base Class Library, or the .NET Framework Class Library, all the classes are organized into namespaces. And you think of a namespace as a last name for classes. So my first name is Bob, but there are literally hundreds, if not thousands, of Bobs in the small town that I live in. If somebody were to say, Bob likes coffee, well, you might ask, okay, but which Bob? There's probably like 10 million Bobs in the world. If they reply with my full name, Robert Theron Tabor, that Robert Theron Tabor likes coffee, well, now you should have a pretty good idea of who they're talking about. I'm pretty sure that the uniqueness of my middle name in combination with my first name and last name are pretty unique, so that might only identify one person in the entire world. The same is true with classes in the .NET Framework class library. With tens of thousands of classes in the library, it's possible that a single name is shared by more than one class. However, by using the namespace of the class, it removes the ambiguity. While you might know which version of the class you intended, the C# compiler, as it tries to make sense of your code and tries to create an executable file from all the code that you've written, it tries to resolve any references to the classes that you've used or you've referred to within your code. And we saw that a few lessons ago when I typed in the word stream reader, the Visual Studio IDE let us know that it didn't recognize the class name at all. So when the compiler is confused, it stops immediately. It forces you to explain further what you meant, and we call that a compilation error. So if I wanted to reference the stream reader class, I could do this by using its full name. So system.io.streamreader my stream reader equals new. And so I could do it like that. So system, as you can see here, its full name, system.io.streamreader. The system part is a top-level namespace that many other namespaces and classes belong to. Secondly then, after system, there's the IO namespace, and it contains other namespaces and classes that deal with in and out, or rather getting data into and presenting data out from, or sending data out of the application. And then third, we see the name stream reader, which is actually the name of the class. So the system.io namespace illustrates that namespaces can, and often do, contain other namespaces. You can use any number of namespaces to keep classes organized and avoid naming collisions. However, the developers at the .NET Framework Class Library realized that too deep of a nesting structure would add complexity. So if you're ever in a position to create libraries of functionality specific to the company that you work for, you want to strive to use as few as necessary in order to help those consuming your code. Again, the creators of the .NET Framework Class Library try to keep it at 2 namespaces, then a class name. Occasionally that extends to 3 namespaces and then a class name. But they try to keep it pretty short overall. So you're looking at this and you might say to yourself, well, wow, that's one really long line of code. I mean, we were able to do it much more succinctly before, right? So how am I supposed to, first of all, memorize all of this? Well, while IntelliSense helps initially, most developers use a simplification. In fact, you've been using this and you may not have already realized it, and that is the using statement. So most developers rely on using statements to shorten the amount of code that they have to write. A using statement provides access to all of the namespaces and classes that belong to it so that you don't have to type it all out. So you're telling the compiler, hey, I'm using these namespaces, so before you complain and tell me that you can't find a given class name, please check these namespaces first, all right, the ones with the using statements there at the very top of this code file, to ensure that the class that I'm referencing in my code belongs to one of them. If you don't see it in there, then you can complain. So that's what we're telling the compiler by using those using statements there at the very top. So notice that there are this set of using statements were added by default whenever we created our project. The project template that we chose, the console application, adds these as a convenience so that you don't have to add them yourself. Now you could remove the using statements that you know you're not going to need. Like for example, I may know for this particular application I don't need system.collections.generic. I could remove that and there would be no harm done to my application. But honestly, there's no real reason to remove them as far as the compiler is concerned. It'll compile the code the same regardless of whether or not there are extra unused using statements. Some developers prefer to keep this list tidy so that they know when they're looking at the code exactly what's going on. So removing unused using statements helps them comprehend the code a little bit better, and so that's usually the course that many professional developers take. You can decide for yourself if that's something you prefer to do once you get more experience. For our purposes in these tiny little applications, it doesn't matter one way or the other. But when we're maintaining a larger code base and we want to be expressive in the code that we're writing, then we might take more time to manicure those using statements at the top of every file. All right, so let's do this. Let's comment out this line of code. We've taken this next step before, but I just want to revisit it in the context of this conversation. So we want to create stream reader, my stream reader equals new stream, stream reader, like so. And the IDE lets us know that it's not able to resolve the name stream reader because we haven't referenced its full name. So we see those little red squiggly lines under the word stream reader. And you know, we've noticed this before. Whenever I put my mouse cursor on that line of code, there's a little glimmer of hope. A blue dash appears underneath the letter S in Stream Reader, and that means a contextual menu is available. And so there's a couple of ways to invoke this contextual menu. The long way is that I could hover my mouse cursor over that little blue dash. It opens up a little contextual menu glyph, and then when I click down on the down arrow, it actually opens up the menu for me. And you've seen me perform this technique the last time that we attempted to work with the Stream Reader back in lesson 11 or 12. Now, the more convenient way to resolve this namespace is to use a keyboard-only shortcut that most professional developers prefer. And so using the mouse technique, once you hover over that blue dash, the context menu appears. The very first option is using system.io. If it's not already highlighted, you can use your down and up arrows to actually then press the enter key on the keyboard. So you can see what it did here. It actually added that system.io. But I'm going to remove that, and we're going to take the other tact, which is to actually use the control key on the keyboard and the period, and that will open up the menu as well. So your hands don't have to leave the keyboard. You just can hit control period on the keyboard, and it pops open that little menu, and then I can just choose the up and down arrows, use the enter key on my keyboard, and it accomplishes the exact same thing. Okay. So the control plus period is a better approach because your hands, again, don't have to leave the keyboard. It allows you to stay in flow and continue to work without having to move context back and forth between mouse and keyboard. Okay, so occasionally whenever you attempt to use a class in the framework class library, you'll get an error that says something about there being ambiguity. The reason is that you have two using statements that both happen to have a class with the name that you're trying to use. So in that case, where you have two using statements, and both of those using statements have a class that shares the same name, then when you try to use that class name, you'll get the ambiguity error. What you'll merely have to do in that case is use the full name for the class that you're trying to reference, like we've done here. All right, and that will get your code working again. So one last tip, if you need to look for help on a given class name or a method name, sometimes when you search, you might want to add the entire namespace, like what I have highlighted here. Otherwise, you might be looking at the help for a different version of the class that belongs to another namespace. I've made that mistake before. All right, so before we close this discussion of namespaces, let me point out three basic things. First, every class that you write, whether it's part of the program.cs file or a custom class file or in an ASP.NET web page or a Windows form, it'll all be contained within a namespace. Now, we've glossed over the namespace declaration in the file that we're working with until now. Like, for example, in this project, it's namespaces and referencing assemblies. Where did I hear that namespace name before? Oh yeah, it's the name of the project that we typed in ourselves when we created a new project. So the default namespace will be the name of your project. For simple applications, you may never need to modify or add additional namespaces. Secondly, you can set the default namespace in the project's properties if you want to change what that default namespace is. So what you can do is just right-click on the project name and select the Properties option at the very bottom. And then you can see here on the Application tab on the left, there is a text box called Default Namespace where you can see by default it's set to the name of our project. And so the technique is easy. The reason why you'd want to choose to change it from the default is a little bit more advanced. So for the sake of keeping this topic simple, I'm just going to encourage you to revisit this idea after you're more experienced in software development and you're thinking about things like solutions that have multiple projects, the purpose for each project in the solution leading to a larger application architecture. Okay, those are not things we're going to talk about in this series, but they're definitely pertinent whenever you get out and you're building applications, larger scale applications in larger companies, and that's something that will have to be dealt with a little bit later. All right, and then the third thing that I want to say before we leave the topic of namespaces is that you can create new namespaces for your own code. Again, the technique is really simple, but the reasons why you might choose this are maybe a little bit more advanced from where we're at right now. Again, if you set out to build a large software application and you want to organize your code into namespaces, or organize your code, you'll want to do it using namespaces, and it'll become important to you at that point. We don't want to talk about it for now. Okay, but what we do want to talk about is the next important topic related to code organization, and that is, in an effort to keep the .NET Framework Class Library manageable, the developers broke up all those tens of thousands of classes of code into a few dozen actual files, DLL files. Now, if you had to load one monstrous library of code up into memory every time your application ran, Most of these classes, tens of thousands of classes, you're never even going to use in your application, never even going to reference. Then each time you ran a .NET application, it would take up the entire computer's memory, and it would be extremely slow, and they didn't want to do that. So instead, they put related functionality across many different namespaces into a few dozen .NET assemblies, a few of these DLL files. So when you create a new project, the template for that project includes several references. Here we can see them right here. Several references to core assemblies by default. So for example, if I wanted to create a WPF or Windows Presentation Foundation application, and I chose the WPF application template whenever I went File New Project and saw the New Project dialog in Visual Studio, the template would add references to several important assemblies that are required in order to build WPF applications. So as you can see, I've expanded out that references entry here in the Solution Explorer to see which assemblies have been added by our console application project. And then if you were to click on one of these, for example, just System, you can see in in the path property here, and we'll have to expand this out a little bit. Oh, we're going to have to expand it out a lot, aren't we? Oh my goodness. Okay, here we go. Let's hover over it. You can see where that particular assembly is stored. It's stored in this program files x86 reference assemblies, Microsoft Framework, .NET Framework v4.5, system.dll. Okay, and let's take a look at system.core, and it's in that same folder in the system.core.dll file. All right, so you can see where those assemblies live on your hard drive if you want to. So what happens whenever you realize that you need a part of the .NET Framework class library that has not already been added to your project? Simple. You just have to add a reference to that assembly. In fact, this isn't only true for assemblies that were created by Microsoft and are part of the .NET Framework class library, but it's also true of third-party assemblies that you want to use in your applications, whether they're commercial products that you've purchased from some third-party vendor, or they're open-source libraries that you download from, from some source online, or even libraries of business rules that are specific to your company or organization that one of the developers in the next cubicle created. You have to first add a reference to the assembly in the project so that when you reference the namespace and the class name in your code, like we just looked at here, it'll know, the C# compiler will know which files to look in for the actual code implementation. So since I want to keep this example as simple as possible, I've created a very, very, very simple library of my own. It's simply called Tabor, and it's in the file called tabor.dll. And my Tabor class has a single class called Bob, the Bob class, in the Tabor namespace. All right? And so my Bob class has a single method called lookup, which accepts an input parameter of type string that represents a URL from a website, any website you can give it. And then the lookup method will pull down all of the HTML from online for that given web page from that URL. So you can find the tabor.dll file that I created and I distributed with these lessons in a zip file that accompanies this lesson, lesson number 18. And so I've already, if you look in my documents directory, I've unzipped that particular zip file into a directory called lesson 18, and I've already got that tabor.dll file on my hard drive. So make sure that you have unzipped it someplace where you can get to it if you're trying to follow along in this lesson. The documents directory is fine, to your C drive is fine, whatever you feel comfortable with, okay? So now that we've located it, as I was saying earlier, to actually use that assembly, the code that I wrote and I've distributed in my own project now, I have to reference that assembly from within my project. So there's a couple of different ways to accomplish this, but for now I'm just going to, let's close that down, close that up. What I'm going to do is I'm going to right-click the project name in the Solution Explorer, and I'm going to click Add, and over here in the submenu I'm going to select Reference. All right, and that'll pop open the Reference Manager dialog. And so notice that there's some tabs along the left-hand side. that change the types of assemblies that are displayed there in the main pane. So for example, by default, you're going to see all the assemblies that are available from the .NET Framework class library here. And you can see little check marks next to the ones that are already part of a project. Cool. All right, so since we're referencing a custom assembly that's in the Documents directory, what I'm going to do is click the little Browse here, and it says there's no items found. So I'll click the Browse button at the very bottom of the dialog, and this will pop open another dialog that allows us to select the files to reference. So on the left-hand side, I'm going to look for my Documents directory. There you are. And the Lesson 18 subfolder. There you are. And here's that tabor.dll file that we're looking for. I'm going to make sure to select it and then click Add. And now you can see that it is selected here inside of my Reference Manager dialog, and I'm going to click the OK button. And now if you take a look at our at the Solution Explorer and go to the very bottom, you can see that we have added a reference to the tabor.dll file that was out on our Documents directory. Great. So now that I'm referencing that assembly, I want to use the features of the Tabor assembly, the tabor.bob class, and I'm going to write the following code like so. Here, let me comment this out, and we'll start afresh below it. Here we go. So Bob, oh, can't find Bob. I'm going to hit Control period on my keyboard, and see, it found it using Tabor. I'm going to add that using statement. Now I can do the following. Bob equals new Bob. That's an odd thing to say. So string HTML equals bob.lookup. See, I have one method there. I'm going to give it a URL. So let me give it a URL to my own website, http://www.learnvisualstudio.net. And then what we're going to do is a console.writeLine. And I'm going to give it the HTML string. And then console.readLine. All right, and that's all we'll need to do. And so now what I want to do is go ahead and run the application. Cross my fingers, hope it works. Awesome, it worked. So if I were to scroll up in this window, you can see there's so much content here on that home page that it didn't really easily fit in one viewing, so you have to scroll up and down. But there's just HTML there from the home page of my website. Very cool. And I'll just go ahead and enter to exit that. Great. So now what we want to do is actually open up Windows Explorer, and I want to see what actually happened in the bin/debug directory of my project. So let's go to Documents, Visual Studio 2013, Projects. I'm going to look for the Namespaces and Referencing Assemblies Solution folder. Then I'm going to look for the Project folder, and then I'm going to look for the Bin folder, and then I'm going to look for the Debug folder. All right, so here we can see that we have our actual application, the .exe assembly, .NET assembly. And then there's a bunch of files that we noted before that are used for Visual Studio, syncing up, debugging features, all that good stuff. But here also we see the tabor.dll file that's added as a result. You can see that the assembly is copied to my output directory, in this case bin.debug, which I'm going to need to distribute with my app whenever it's put on somebody else's computer. So you might be wondering, well then why don't I need to distribute, why didn't it put all the other assemblies in here from the .NET Framework? That's because in order for somebody to use your application, say you wanted to create a release version of your application, they already need the .NET Framework installed on their computer, and they need it updated to the version that you're using and that you compiled against when you went to build your solution, build your file, your assembly. Okay, so they already have it on their computer. It's just going to reference it in a common place on the computer called either the global assembly cache or in a specific location to the .NET Framework. The .NET Framework will find the files that it needs, that it knows it needs, that it's familiar with, that were packaged with it. Okay, so you don't have to worry about that. Just any custom assemblies like the tabor.dll need to be then distributed with your application. All right, I realize that I just kind of brushed through that last part. It's not all that pertinent for now. Just it just works. Okay, as long as somebody has the .NET Framework class library and the .NET Framework installed, the runtime installed on their computer. Okay, so we learned in this lesson how classes are organized into namespaces to help disambiguate class names, or rather how to avoid naming collisions between two classes that have the same name but are in two different namespaces. So we talked about the using statement that allows us to shorten the full name of the class, namespace, namespace, namespace class, to just using the class name, and it basically, the using statement just tells the compiler that it should first attempt to resolve all class names against those namespaces that we've added into the using statements at the very top of our code file. I also demonstrated how to use the IDE to help find namespaces for classes that we want to use within our application. The little helper menu where you hover over it, and then also the control period technique that I demonstrated helps you get to create those using statements automatically. We talked about the topic of how code is packaged into assemblies, and that when you create a new project from a new template, part of the job of the template is to add references to commonly used assemblies. The .NET Framework class library is so large that it wouldn't make sense to add a reference to every single namespace and class all at once. However, if you need something from the library, you may need to add a reference to an external assembly. So additionally, many companies have created their own libraries of code that you may need to use if you go to work for them that encapsulate all the business logic necessary for a given area of their business. Also, there are third-party vendors as well as open source projects that provide libraries that you might want to use within your application. So in these cases, you have to add a reference to the assembly that contains the given library of code that you want to utilize, and then you can go ahead and use it within your app. Okay, so next up we're going to talk about those mysterious words, private and public, that keep popping up. We've ignored them until now, but we're going to discuss what they are in the very next lesson, so we'll see you there.